I squared.
2 plus 3i to the third.
Write it out for
Yes.
Oh, yes. I think this still works.
Actually, I'm just going to use the shortcut on this for the squaring. 4 plus 6, 12i. So you remember the shortcut where you multiply them together and double it? Do not expand without simplifying this. So 9i squared is -9.
Jillian.
Yeah, you got more terms than you want. -5 plus 12i times 2 plus 3i.
Yes.
-10 minus 15i plus 24i plus 36i squared. -46 plus 9i. Let's check if I'm right. I believe I am. Yep. And yes, you could just type that right into your calculator. Do you remember where the I button is?
Yeah, it's the pi. Like
It's next to pi,
and
yep.
scroll.
So,
Oh, yeah.
graphing in the complex plane. So, I think I showed you this a little bit. Part of today's lesson is kind of short. 3 plus 2i, -2 plus I, -3 halves, -3 halves I. So, the name, and it's important to remember this name because it Argand plane or an Argand diagram.
Yeah.
2 minus 3i. -2 plus 3i. And they have me do I and -I. What do you notice about these relationships?
Um, they're like 180 degrees.
It's a 180-degree rotation. Yep.
We just switch the
So the opposites, Z and -Z, are 180 degrees of each other.
opposite signs.
So, what's called modulus argument form, according to this book, aka polar form. Do you remember polar form at all from last year?
Yeah, points.
Polar form of a complex number has a
Radius angle.
radius angle. Yep.
Yeah.
So
And I only remember converting from rectangular. Well, I guess these are rectangular.
you're gonna go it's rectangular to polar. Yep. So sketch on the graph the complex number W on the Argand plane given it's 4 units away from the origin and makes an angle of 45. 445. And we could write that as 4 cosine 45 degrees plus I sine 45 degrees.
Oh, this is coming back to me.
You remember that?
It looks familiar, yeah.
And the reason it is,
Wait, that's the equation for just the
that's the
coordinate.
polar form.
This
Hmm. So
No.
this,
Last year.
the x coordinate is 4 cosine 45. The y coordinate is 4 sine 45.
It's just pretty.
Uh-huh. And the y coordinate has the I, doesn't it? So when you distribute,
Sense more than it did last year. Seems pretty simple now.
it's actually not that hard
I don't know. I thought this was.
because it's new and different. We have an abbreviation that you may now use.
Yes.
Cis.
Sis.
That means cosine 45 plus I sine 45. This angle will always be the same.
Okay. Yeah.
If we foil that.
Cosine plus I sine.
Hmm. Does it do Euler form in this one? I'm going to teach you Euler form right away too,
Okay.
because your calculator gives it an Euler form.
That's E. Well, you are.
Euler form, yes. Why this is equivalent?
E.
So this one would be, this one in Euler form is 4e, the number e, to the I times 45 degrees. Usually Euler form is done with radians. So that would be pi over 4. This would actually be that's probably more accurate. You notice when your calculator was in degrees, it gave it with the number and the angle in degree mode.
Well, wait. E. Wait, we got 4E to the I
Theta.
45. We are going to put it into a radian.
I'm not sure that Euler form actually applies to degrees.
I'll make them not use degrees.
That also applies when we do calculus. It's convert. It's possible to do it without, but it's way harder. Much harder than converting.
Well, I guess divide
Yeah.
180 by 180.
Oh, no.
To go to degrees,
Radians.
no, multiply by pi over 180 to go to radians. Radians are always smaller. Okay, so now we're going to convert this to argument form or to polar form. So first thing I need to do is the modulus, which I just do by the Pythagorean theorem. Modulus is radius.
Okay.
Yes, put that in your notes. Radius is very easy. You'll just use Pythagorean theorem.
Your noise. No, it's all, it's no other.
I'll get the angle with an inverse tangent. My calculator turns on, we'll get that. Does that kind of make sense?
Wait, yeah, wait, what are these like, so if it,
The radius is simply the hypotenuse.
no, but if we put, like Z with the absolute value, it's like magnitude.
That mean find,
Wait, is that just
that means
Radius.
modulus,
like this?
The wall.
which is radius, yes.
Purpose. Oh, yeah.
Oh. It's great.
That easy enough? Draw the triangle though, it helps. Or draw it on a graph and then draw the triangle. So you can do it in either form. If you're doing CIS, if you're doing Euler, it needs to be radians. Find the modulus and the argument. So I'm just going to write these all in polar form. 2 plus 3i. Square root of 13. And then I have to do inverse tangent of 3 over 2.
Oh.
This next one, -1 square root of 2. 1 plus 2 is square root of 3.
Your like number of readings should be less than one, right? Because if it's more than one, you're over at 180 and you should just do a negative angle, right?
So when I did this, when I did the inverse tangent here, the inverse tangent, remember from trig, only gives me values in quadrants 1 and 4. So it gave me a value of -0.95. I know that would be over in quadrant 4.
So you have to take the negative radius. Well,
So I just add pi. I could take the negative radius.
that seems harder.
Oops, I multiplied by pi.
Well, but like you just like if you're especially if you have more than two, you've done something. No, never mind.
So we can go all the way around 2 pi.
So
So it can be up to 2 pi
2.1.
because that's this angle. It's less than pi. Pi is 180 degrees to, so we haven't gotten all the way to pi. So we're less than 3.14.
Okay, I never mind.
That makes sense?
Yeah. We're going on a scale of 360 or like, because it's a circle is 2 pi. right?
Circle is
So I
2
was like,
pi.
oh, it's out of 2.
No, it's out of 2 pi, 6.28. So my hypotenuse here is square root of 3 squared plus 5 squared. That's square root of 34. My angle. So this spits out 1.03. But that's it over here, right? So I must add pi. And the last one would be quadrant 4. I believe this would be 9, that's square root of 13 again.
Well, we are.
If it does not specify 3, I can actually, it is okay if I leave it as negative. If it does not specify where the angles need to be, they totally, yeah, they did them all in degrees, but same. Oh, they gave quadrant 3 as a negative angle. So instead of, they measured the angle that way. We measured it this way. Both are correct. Unless they give you an angle range. Does that make sense? That's all there is to this section.
Give me points.